Hi, this is Brian Thomas. Want to go over a lesson in Unit 1 of polynomials. This lesson is going to be on adding and subtracting polynomials. So I just want to kind of go through some of the vocabulary as we go along here. So in adding and subtracting polynomials, some key vocabulary that we want to kind of talk about. Of course, the variable, notice how it's a letter that represents an unknown until it's given an identity. So it's got to be defined in some way. If it's not defined, then it just stays as a letter. And as we mentioned in class, the most common letter for the variable is X. But again, it can be any letter. It could be A, B, or C as well. Or, sometimes we even use N quite a bit, but X is the most common one. When it comes to the word coefficient, as we said, that's a very mathy word, and coefficient is the number in front of the variable or variables. And again, the key here is it's connected by multiplication. And the thing in algebra is we actually don't show the multiplication symbol. We just put the number next to a letter and it's understood to be multiplication. So for instance, if I put a 2 in front of the X, that 2 is called the coefficient. Or if I have a -3 and that put that in front of, say, an N, that would also be considered, the -3 would be called the coefficient. So the number in front of the variable is referred to as the coefficient. When I use the word term, the term is a number, or it can be a variable, or it can be a product of numbers and variables. Again, the key to a term is everything has to be connected by multiplication. That's the key. If it's all connected by multiplication, then in algebra, we call that a term. So our favorite number we mentioned was 7. So 7 can be an example of a term. If I talk about a variable, I can use the letter X as a term, or a product. So I could say maybe, 7 times X. That could be considered a term. Something we'll talk more about, but we also can be using exponents. So if I have, say, like 2x to the third, remember that means 2 times x times x times x. So since everything is connected by multiplication, it's also called a term. So 2x to the third would be considered a term. Notice the x is the variable, and the 2 would be the coefficient, and the 3 would be called the exponent. Notice again, 2x to the third is the simplest way to express it. This is the long version. In algebra, we like to write things in a simple form. So we leave it as just 2x cubed, or 2x cubed as a short version. Another important vocabulary is what we refer to as like terms. So like terms is when we have the same variables, and we have the same corresponding exponents. When we talk about like terms, the coefficient does not have to be the same. It's all about really focusing on the variables. So if I give you, say, 5x, and I give you a -7x, notice how we have the same variable. So these are considered like terms. Or if we have, say, 4x to the third, and we have, say, x to the third. Make it better 3 there. So x to the third. Notice how we have the same variable raised the same exponent. So these are also considered like terms. Unlike terms is when the variable part is not the same. So an example there would be if I have, say, 5x and 5y. Those are unlike because they do not have the same variable. So it doesn't matter what the coefficients are, it's all about the variable. And since the variables are different, we call that unlike. Another example would be, I could have 6x and, say, -5x squared. Notice how, again, we have the same variable, but they have a different exponent. So we would describe those as unlike terms. So stop for a second here, pause. So as we move along here, I'm going to kind of move on past these terms here: monomial, degree, binomial, all this. And I'm going to drop down here to some key skills, and we'll come back to these other terms in a little bit. So in talking about key skills, it's important to understand how to add and subtract positive and negative numbers. So again, when we work with positive and negative numbers, one of the old things that we talk about is we think in terms of money. So if we think in terms of money, positive numbers is going to be income. So positive numbers we describe as income. And neg numbers we describe as debt, money that we don't have. And again, the plus sign means we're combining. So if I look at this example here, we have a -8 and we're combining it with a -2. If you have an $8 debt and you're combining it with a $2 debt, your debt should be a -10. That's how I can reason this out in my head. As far as the shortcut goes, is the rule, if the signs are the same, all we really do is just simply add the numbers, but we keep the sign. So if I'm doing this mentally, -8 plus -2, I recognize that they have the same signs, they're both negative. So in my head, all I really have to do is add 8 plus 2, which is 10. And since they're both negative, we keep that as a -10 as our answer. So if I have another example, if I have, say, -4 plus -12, notice how the signs are the same. So I really, if I'm using my thinking of money, I owe $4, that's a debt of $4, and you're combining it with a debt of $12. So therefore, the answer would be -16. If I'm using the rule, notice how we have both negative numbers here. So we add the numbers together, 4 plus 12 is 16. And since they're both negative, we just keep the sign as a negative, and -16 becomes our answer. As we look into this next example, adding with different signs, what that means is one number is going to be positive or negative, and the other number is going to be different. So notice I have a -10 and a 3. Those numbers have different signs. If I'm using money thinking, the -10 means I'm in a $10 debt. I'm down $10. But if we combine that with $3 of income, income actually removes debt. So when we hear that word remove kind of implies that we're dealing with subtraction. So even though this says add, mathematically, we actually have to subtract. So that leaves us with a $7 debt, because remember, we're trying to get out of debt if you're paying income. As far as the rule goes, if the signs are different, if one number is negative and one number is positive, the math really is just simply subtract the two numbers. So notice how we have a 10 and a 3. We just say 10 take away 3 is 7. But the catch is you have to keep the sign of the larger. And since it's more negative, it has to remain negative because we were not out of debt. So if the signs are different, we actually subtract. 10 take away 3 is 7, but since it's more negative, it has to remain negative. That's what this kind of means. If I look at this example, notice how we have 10 plus a -3. 10 plus -3, notice how, again, the signs are different. So what we do is, again, we subtract. 10 take away 3 is 7, but notice how it's more positive this time. And since it's more positive, it remains positive, because $3 of debt does not make me go in debt. It just makes my income go smaller. So notice how we have this concept of, removing or taking away, if you will. That's kind of a subtraction concept. So that's kind of confusing in math sometimes. Even though it says add, since we're dealing with positive negative numbers, when the signs are different, it's actually subtraction. So we'll catch a breath here again. So as we move forward, something we want to bring to your attention is, we mentioned this word term. One thing we pick up on in algebra is when adding and subtraction are present, there are more than one term present. So keep that in mind. When adding and subtraction are present, there are more than one term present. So this is where we start to shift over to this concept of terms. And what I like to do is I like to use what's called the circle method. So in this example, I have this -8 take away 12. Notice how we have subtraction present. So there's more than one term present. And the way we identify the terms is we use what's called the circle method. So what we do is we circle the first term. And when circling the next terms, we have to include the operation inside the circle. So notice how I had this -8 take away 12. Using the circle method, we circle the -8, but when we circle the 12, we include the operation with it. And here's the catch. When I use the circle method, we always add what's inside the circles. So this problem turns into an addition problem. And what we do is we use the addition rules that we just talked about. So this problem turns into a -8 plus a -12, which gives me a -20. It's very important in algebra that these are addition, because addition allows us to move things around. So keep that in mind, that I could also rewrite this as -12 plus a -8, and it would still give me the same answer. So that's why we like to rewrite these as addition problems. And that's what the circle method is focusing on, is more about addition. So when I have a 7 take away -5, when I use the circle method, the 7 gets circled. But when I circle the -5, I have to include the subtraction sign with it. And this now turns into an addition problem. So what's in the first circle is a 7. My second term is a little strange. Notice how it has a dash in front of the parentheses. That dash in this situation, when there's a dash in front of the parentheses, when there's a dash in front of the parentheses, that dash means instead of minus, it actually stands for the opposite of. So what you basically are doing when you see a dash in front of the parentheses is this means to take the opposite of a -5. So in other words, this really is the same thing as a 5. So instead of seeing this as a 7 and a negative of a negative, we really write this as a 7 and a 5. So this problem turns into 7 plus 5, and 7 plus 5 turns into a 12. So that's kind of the cool thing that we do in algebra, is we kind of start to see this math turn into what we call terms. And terms are separated by adding or subtraction. And when I use the circle method, this always becomes an addition problem. Okay, so we'll pause again for a second. As we move into this next part, what I want to mention here is a lot of things we take for granted, because a lot of information we just have memorized, and so we really don't pay attention to some of the details. So an important concept is how multiplication and exponents are used as shortcuts. So we really never think of them as shortcuts, but they actually are when it comes to writing math on paper. So remember, with multiplication, again, parentheses can be used for multiplication. So this means 3 times 5. 3 times 5 also is the same thing as 5 plus 5 plus 5, which in turn equals 15. So what we're getting at is 3 times 5 is a simple way to write 5 plus 5 plus 5. So if I have a problem like, say, 2 plus 2 plus 2 plus 2, there's an easy way to write that. Since there's 4 2's added together, we can also just write that as 4 2's, or 4 times 2, if you will. So addition problems like this can be used, we can use multiplication as a shortcut. So when it comes to start to work with coefficients and variables, notice how this is 3x, but also remember 3x means 3 times x. And 3 times x is the same thing as x plus x plus x. And since x is an unknown, the simplest way to write it is just back to 3x. So if I have an expression like, n plus n plus n plus n plus n, that's a pain in the butt to write. So what we do is, as a shortcut, we invoke the multiplication concept. So since there's 1, 2, 3, 4, 5 n's connect multiplication, we can change this to 5 times n, or simply 5n. So 5n is the simplest way to express that. So when it comes to 2x, notice that 2x means x plus x. But again, 2x is the simplest way to write it. It's the fewest symbols. And that's what math is about a lot of times, is trying to communicate math using as few symbols as possible. Notice though, however, 1x is the same thing as x. So x is actually the simplest way to write this. So one thing we need to bring to your attention is when we just have an x, remember its coefficient is understood to be a 1. So we don't write the coefficient of 1 down in algebra. It's understood to be there. So when you're doing math on your homework, never leave a coefficient of 1 in the problem. Always drop that 1, that coefficient of 1. Now, when it comes to exponents, if I have x to the third, that's the same thing as x times x times x. But notice x to the third is the simplest way to write that. If I have x squared is the same thing as x times x. But again, x squared is the simplest way to write it. X to the 1 is the same thing as x. But here, notice again, this is a little bit different. X is actually the simpler way of writing it. So one thing we need to bring to your attention is when the exponent is 1, we don't write it. We leave it as simply x. So if I ask you what the exponent of x is, it's understood to be a 1, but we don't write the 1. But that's how that math kind of works. And something else we won't go into a lot of detail here is x to the 0 power. X to the 0 power actually just represents the number 1. So these are interchangeable. So if the x has an exponent of 0, the variable basically disappears from the problem, and it really just represents a 1. So this brings us to combining like terms. So combining like terms is all about writing the answer in the fewest symbols possible. But before we do that, though, let's understand what this problem here means. So if I ask you to simplify 4x plus 3x, so 4x plus 3x, notice how 4x means 4 times x. And remember, 4 times x means there's 4 x's added together. And what we're doing is we're adding another 3 x's. So that means we have 4 x's and then we have another 3 x's. So really what you see here is we have then the simplest way to write that would be 7x. So since there are, like I said, 7 x's added together, the simplest way to write it is, again, like we said, 7x. So 4x plus 3x, again, 7x. Now, instead of going through all of that, we talked about like terms. The easiest way to do this without a whole lot of thinking is to identify the two terms by using the circle method. If they're like terms, what we're allowed to do is we're allowed to add the coefficients and keep the variable the same. So if I look at this 4x plus 3x, notice how I can circle the 4x and I can circle the plus 3x, which means my two terms are 4x and 3x. And since they have the same variable with the same exponent, we call these like terms. And since they're like terms, all we really have to do is add the coefficients. So 4 plus 3 turns into 7, and that gives us 7x. So that's how that problem can kind of be done. So in this next example, I have 10x squared take away 5x squared. Notice again how, since subtraction is present, we can actually use what's called the circle method. So what I can do is I can circle the 10x squared, and I can circle and make that negative 5x squared. Those are my two terms. Now, since they have the same variable raised to the same exponent, all we have to do is focus on the coefficients. So all I really got to do is go 10 plus -5. And when adding integers, adding positive and negative numbers, the signs are different. And since the signs are different, we actually subtract. So that really means 10 minus 5, which would be 5. And we keep the sign of the larger value, which is a positive 5. So the new coefficient is simply a 5. So that becomes then 5x squared. That's one way to see this problem. So let's see what else we can get into here. So when it comes to looking these few more examples here, we have 3x to the fourth take away a negative x to the fourth. And again, since subtraction is present, we can identify the terms using what we call the circle method. I can do better than that. Let me erase that there. Oops. Get the eraser there, get that out of there. Oh, let's pause a second here. Technical difficulty. So let's try that again. So I have this 3x to the fourth take away this negative x to the fourth. Again, using the circle method, let's see if I can get that to work for me. I'm going to circle this 3x to the fourth, and I'm also going to include the subtraction sign here in the second part. So those are my two terms. So what I see is there's now a 3x to the fourth. But notice that this second piece actually means the opposite of a negative, which makes it a positive x to the fourth. So what we do is we bring down just plus x to the fourth. And again, if I want to use the circle method, and by this point, you can kind of start recognizing what your terms are without the circle method, but I'm going to go ahead and circle again. But the circle is optional. So that's my first term, and this is my second term. So once you recognize that you have those two terms, and they are alike, and since they're alike, we add the coefficients. Remember, 3 is the coefficient here, but notice how we don't see a coefficient, but it is understood to be a 1. So that would make that then 4x to the fourth. So if I look at this next example, negative 9x plus 8x, again, if I want to identify my terms, a circle. And so we now look and see, are these terms alike? Since they both have an x with the same exponent of 1, we call those like terms. So all I have to do is add the coefficients. -9 plus 8 would be negative 1x. And recall, though, that 1 is not used as a coefficient. So we drop the 1 and just leave the negative there and call it negative x. Now let's get more into what I would say is kind of the core of our assignment. Adding and subtracting polynomials is really what you're going to be seeing in Blackboard. And again, some key vocabulary we need to be picking up on is, first is this word monomial. Monomial just means one term. So remember, a term was a number, a variable, or product of numbers and variables. And remember, exponents also represents multiplication, so you'll see exponents there as well. What's important here again is the coefficient can be any number. And what we're going to be working on is really single variable monomials. So we'll most commonly be just using the variable x on a lot of our math. Something else to pick up on is, at this point, is I really want to talk about this word degree. So in math, this word degree is brought into play. The exponent of the monomial will be called the degree of the term. So if I look at the variable, the exponent of the variable is going to be called the degree of the monomial. So in this example here, the degree is going to be a 3, since that's the exponent. So when I talk about a monomial and I'm talking about the degree, what we're focusing on is the exponent of the variable. So if I look at this term here, notice that its degree would be the 4. So it's important as we move forward to also pay attention to degrees. Notice the coefficient there would also be a 1. Now, if we look at this 6, notice we have to identify its degree. But notice that there's no variable there. And remember, to identify the degree, it's the exponent of the variable. Remember, though, the variable disappears if the exponent is 0. So actually, there's an x to the 0 there, which means I can identify the degree of a 6. The degree is going to be, in this case, a 0. As we move forward, some other vocabulary words we want to talk about. A binomial is 2 terms. So if I give you, oops, lost myself there again. So as we move into binomials, binomials, again, as we were saying, is 2 terms. So when I talk about 2 terms, I could have, say, maybe 7x to the 3rd plus, say, 5x. That would be 2 terms. When we start writing polynomials, what's important to also pay attention to is we want to probably write the degrees from largest degree to smallest degree. That's a good way to keep things organized, is the degrees come into play in making sure that it's in some type of order. So if I'm talking about a 3-termed polynomial, we call that a trinomial. So if I have like x squared minus 5x plus 6, that would be considered a trinomial since it has 3 terms. Excuse me. So, and again, as we move forward, we get into now, there's that word polynomial that I just talked about. So a trinomial is 3 terms. A polynomial is going to be 2 or more terms. Again, in our math, when working in polynomials, we're just going to work with a single variable type of polynomials. Again, the exponent is going to be referred to as the degree of the term. Now, the degree of the polynomial is represented by the highest degree term. So there's also the degree of the polynomial. So we also have this word leading coefficient. The leading coefficient is going to be the coefficient of the highest degree term. Also, we have this vocabulary, the term that is only a number, in other words, there's no variable, is a lot of times called the constant. The variable is there, but remember, it's exponent to 0, as we mentioned earlier, so it's not shown. So as I look at these examples, I have this 6x to the 4th plus 5x squared minus 9. Notice that the degrees, the exponents are written in a descending order, which is always a good thing. So that helps us identify the degree of the polynomial much easier. So again, if I use the circle method, I can identify my terms. So notice how I have this 6x to the 4th is my first term. This positive 5x squared, or just simply 5x squared, is my second term. And then there's this negative 9. So if you look at that 6x to the 4th, its degree is going to be the 4. If I look at that 5x squared, its degree is going to be a 2. If I look at the negative 9, notice how there's not a variable there. That meant its exponent was 0, so its degree is considered a 0. So the degree of the polynomial is the highest degree term. So 4 is the highest degree, so 4 would be the degree of the whole polynomial. Now, since you put it in order, it's easier to find this leading coefficient because leading coefficient is always going to be out in front. So in this example here, the leading coefficient would be simply a 6. The constant is usually on the other side. It's usually the end. But remember, the constant is only a number. There cannot be a variable there. If there's not a number at the end, then that means the constant was actually a 0. Or we could say, no, there's not a constant. But since there is a -9 there, the constant would actually be a -9. I'll pause for a second. So as we look at this polynomial, I have x to the 7th minus 4x to the 3rd plus 2x minus 8. So there's 4 terms there. If I want to recognize the terms, again, it's easiest if we use the circle method. So again, I'm just going to circle the first term, but I want to circle the second one. I have to include the operation with that. Don't have to be perfect circles, as you can see. Just something to help you focus on. So that's what we're really looking at our LST. Remember, when we're using circles, this is now purely an addition problem. So if I look at the x to the 7th, we see that its degree is a 7. The -4x to the 3rd, its degree is actually a 3. The 2x, its degree would be a 1. Notice how, again, we don't see an exponent, but it's understood to be a 1 there. And then the -8, since the variable is gone, that meant the variable had an exponent of 0. So that degree is considered a 0. So the degree of the polynomial would be the 7. That's the highest degree. The leading coefficient is the number in front. Since there's not one, we understood that that's just a 1. So leading coefficient is actually 1 there. And the constant is the last term. So that's going to be that, that -8. Since it doesn't have a variable, it's called a constant. If it has a variable, then we do not have a constant. So usually the leading coefficient is going to be out in front, and the constant usually is going to be on the other side. So it's going to be on the end. So now we're going to get into the strategy for adding polynomials. So we're going to start to see some parentheses and stuff. But remember, parentheses are a grouping symbol mostly, and sometimes they are used for multiplication. So if I look at this, in this case here, these parentheses just serve as a grouping symbol because there's a big old plus sign here. So what this is saying is I have the binomial 3x squared minus 2x. I'm adding to that another binomial 7x squared plus 5x. So since we're adding here, the easiest way to do this is simply drop the parentheses. So the parentheses are just identifying the two binomials. And since we're adding, like I said, we're just going to drop the parentheses. So this just turns into 3x squared minus 2x plus then the 7x squared plus this 5x. So again, I'm going to be using the circle method here. Lost my colors here, so we'll go ahead and we'll circle that in orange, orange, that, and that. That's my 4 terms, but I'm going to back up here. You know, since there's so many terms, a lot of times, oops, lost that altogether. So since I did that, we'll just turn back to this color. So 3x squared minus 2x plus then the 7x squared plus this 5x. When there's a lot of terms, it's a good idea to slow play the circle method. So instead of circling everything, I'm just going to circle the 3x squared to start with. And what it goes with is the positive 7x squared. And since those are like terms, we now can bring down our 10x squared. Now I'm coming to the -2x. Again, you don't have to use circles. You can use boxes or rectangles as well. There's the -2x, and then there's this positive 5x. So since those are like terms, we add those coefficients, -2 plus 5, and we get, excuse me, we get a positive 3. So that's going to be, oops, let's get back to the color there. So it's going to be a positive 3x. And since those aren't like terms, that stays as our answer. So remember, you can only combine like terms. Unlike terms just have to stay in the problem. So if I look at this example, notice how we now have this polynomial and we're adding it to this polynomial, or you could call these trinomials. And since we're adding, the strategy is actually just to drop the parentheses. So I have this negative 7x to the third plus this 5x squared and this minus 4. And we're adding to that this negative 2x to the third. And we're going to subtract 6x squared and this minus 5. So as we move through this problem, we're now ready to use our circle method. So again, we can kind of slow play this. It looks like I wrote this down wrong here. Let me fix that. That should be actually a 3. So that looks horrible. Let me use an eraser around here. Let's see if I can get that to erase right there. All right. Let's put that back into, make that a 3. Now I think we're ready to use the circle method. So we have this negative 7x to the third, and we have this plus negative 2x to the third. Notice how we really don't need both those signs. That really just means a negative 2x to the third. I could have dropped that plus sign. So I have a like terms there. So negative 7 and a negative 2 would give me then that negative 9. So it's negative 9x to the third. And then if we look at this next pair, we have this positive 5x squared, and we have this negative 6x squared. Since those are also like terms, we want to put those together, and that's going to give me a negative 1x, or again, we drop the 1 and just call that negative x squared. And then lastly, we have this negative 4, and if you want, you can maybe try to draw like a triangle. You like different shapes or not. Triangles are pretty hard to do. So I have a negative 4 and a negative 5, negative 4 and a negative 5. That would be a negative 9. So when I add those together, I would end up with that as my answer. So the answer is actually just going to be a trinomial, since those terms are not like. So now we're getting into the strategy of subtracting polynomials. This gets to be a little tricky. So the way I do this is I deal with the subtraction first. So again, it's all about making these parentheses go away. And to make these parentheses go away, we're going to remove the parentheses. But the way we do this, the subtraction we're going to deal with first. So what we're going to do is circle the polynomials. The subtraction sign must go inside the second circle. Let's do that and see where that takes us. So we're going to circle these two polynomials. So this is going to be this one here. And then this is the other one. Whoa, that really got out of my hand. All right, that's not too bad. So we got those. And what we do though is once we circle the polynomials, we want to then change the signs of the second polynomial. And then we're going to bring down the first polynomial. And then we're going to use the circle method. So the way we actually approach this is we actually deal with the subtraction part first. And remember, when there's a dash in front of the parentheses, it means to take the opposite of what's in the parentheses. So everything inside the parentheses is going to switch signs. They're going to change signs. So that 6x squared is going to turn into a negative 6x squared. That negative 2x is going to turn into a positive 2x. And that 3 is going to turn into a negative 3. And then we can go ahead and just bring down the first polynomial. So negative 4x squared minus this 5x, and then plus this 2. So now we're ready to use the circle method on that. So we have this negative 4x squared, and we do have a negative 6x squared. Notice again, as we do more and more of these, it's always a good idea to make sure you're working with the highest degrees on down to the lowest degrees. So since 2 is the highest degree, that's really who I should be picking on first. And so that does give me then this negative 10x squared. So then my attention turns into the negative 5x and the 2x would be my next pair. So that negative 5x and that 2x. If I'm using circles, it's not a bad idea to say, hey, I'm done with you. I'm done with you. So now you can kind of say, okay, now I'm moving on to negative 5x and 2x. So that's going to give me then this, sorry about that. Let's just make that negative 3x. And then we move into the, these are kind of done now. I have this plus 2 and this negative 3, which is going to give me then a negative 1. So that would be my answer. My answer ends up being just another polynomial. And notice how the degrees are counting down. We do want that. So now we know that the degree of the polynomial is a 2. The leading coefficient is a negative 10, and the constant would have been a negative 1. So it's important to be able to identify those things, and organization helps us see that more easily. So as I move into this next example, so we now see another subtraction problem. And again, as we said, when it's a subtraction problem, it's a good idea to just, let's get that. So we can put this in a circle, and we can put this in a circle. What this has really done for me, it's really focusing on, hey, there's that negative in front of the parentheses. So that's what we really want to deal with first, is the subtraction part. So it's no longer a subtraction symbol. It now turns into an opposite symbol. And since it's an opposite symbol, that just tells me to change the signs of everything inside the parentheses. So 3x to the fourth turns into a negative 3x to the fourth. That positive x cubed turns into a negative x cubed. And then the negative 1 turns into a positive 1. Once I do that, the first polynomial slides down right in front of it. So 5x to the fourth plus 6x squared minus 1. Okay. So it looks pretty good. Now, as we do this, since there's more and more terms, we need to really start to pay more close attention to the exponents as well. So since the 4s are the biggest exponents, I need to put the 5x to the fourth with the negative 3x to the fourth. And when we do that, we see that we have then 2x to the fourth. From there, we can focus on, actually, the x to the third is our next biggest exponent. So we would be zeroing in on him. So this guy and this guy is out of the way. Notice that there's not another term that has a power 3 in it. So he's kind of going solo. So since he doesn't have any like terms, he just drops down into the answer. And then we're looking for, after the 3 would be then the 1 with the 2. So since there's not another term with a 2 in it, he would just drop down as plus 6x squared. So we're kind of now done with him. So now all we're left with is a negative 1 and this positive 1. So negative 1 and a positive 1 just turns into a 0. And so we don't have to bring that down. So that becomes our answer. 2x to the fourth minus x cubed plus 2x squared. So this brings us to the end of our lesson on adding and subtracting polynomials. If you want to take a moment, you can do a review check here. So if you want to pause it and work that out, you can. But before you do that, I do want to bring our attention to that I don't think I filled in my top part here. So let's just do a quick review of some of the vocabulary at the very, very beginning. So notice how we have a monomial. Do you remember what we said a monomial was? So this is a good place to also kind of pause and see if you can kind of remember and define things as we go along. So a monomial, remember, it's simply a one-term expression. And remember, a term could be a number. So like the lucky number 7 could be a term. It could be a variable, like we said, X could be a term, or well, in other words, a monomial. So 7 could be actually a monomial. X could be a monomial, or something fancy like -5x to the 4th could be considered a monomial. And remember, we're working with monomials, I think, in this section, mostly just a single variable is what we're dealing with. Now, remember, the degree was the exponent of the variable. So if I have, say, that -5x to the 4th, its degree would be that 4. A binomial, as we said, is a two-termed expression. So 2 terms. And we could say, like, 5x plus 6 could be an example of a binomial. A trinomial, of course, meant, 3 terms. So you may see, x squared minus 5x plus maybe 4. That's not a really good 4. So if I get my little eraser out here. Plus 4. So maybe you'll see a trinomial looking something like that. And polynomial, we said, was 2 or more. So you kind of get the idea there, 2 or more terms. Remember, the degree of the polynomial was the highest degree monomial in the term. So the degree of the polynomial is just the highest degree monomial. The leading coefficient is the coefficient of the highest degree term. And remember, if the polynomial is written from highest degree to lowest degree, the leading coefficient should be right where it's supposed to be, out in front. And then the constant, remember, we said that was simply the number without the variable. No variable was present. So it's the number without the variable. Because you remember, in this situation, the exponent of the variable is actually 0, so it drops out. So the number without a variable, it's always usually on the end. Should be always on the far right. Okay. So again, if you want to pause the video and we can get back to the actual practice again, see if I can find that for us. Yep, here's the review check here. So you can pause it now and work on those, and I'll come back on and go over the answers. So as far as the answers go, the degree of the polynomial, the leading coefficient, and the constant, we're supposed to identify those. The degree of the polynomial, notice that the degree of the first term is a 2, the degree of the second term is a 1, and the degree of the third term is a 0. Notice you don't actually have to use circles if you don't want to. So the highest degree was that 2. The leading coefficient would be the number out in front, which would be the 7. And the constant would actually be this number on the end. So it's also a 2. So in adding these polynomials, again, since we're adding, we can drop the circles or drop the parentheses, and we can bring down 7x squared minus 5x plus 2, plus then 2x squared minus 3x minus 7. So the 7x squared goes with the 2x squared, which makes then 9x squared. The negative 5x goes with the negative 3x, so it's going to be a negative 8x. And the 2 goes with a negative 7, which makes a negative 5. So that would be our answer. So if you can do without the circles, that's quite all right. Remember here, since we have subtraction, we actually have to deal with this part first. So the signs change. That's going to be a negative x to the 4th, plus 2x, I should say, and actually a plus 6. And then the x to the 4th comes down over here, minus 2x squared and plus 6. So the negative x, the x to the 4th and the negative x to the 4th are like terms, but they would add to 0. So they actually just drop out of the problem. The negative 2x squared, and that should have been actually a 2x squared. I lost it. Exponent there. Negative 2x squared and 2x squared. Those are like terms, but notice how the coefficients will cancel each other out. So we're left with the 6 plus 6, which turns into a 12. So that would be that answer. So that includes this lesson here. Feel free to text me if you have any issues on anything. And I hopefully we can move into the next lesson. Take care.